Okay, so let me give one example. Let's say I have gk, and what I'm integrating here, so to speak, what's the argument to this map now acting on this entire Grassmann algebra? Let's say I have here some gk prime. So what I would like to do is I would like them to disappear from this side. So I want to define this to be gk prime. Now the question is, what happens if I have in this expression? So the extension of the map is done if I can consistently define the map on the entire basis, if I view GL as the complex span, as I was writing there, that's still correct, of G mu, of all G mu's that we have. This is correctly written there. So now on those monomers, I need to define this correctly. So what happens if I have GK prime and GK, for example, and here let's say GKJ? Well, what I can do is I can swap this and then write that I'm integrating against GK again. I'm putting GK here, and then I have GK prime GJ. Okay, this is just using somehow linearity, and then again I'm dropping this, so GK prime GJ. So that's one idea. Now, if you want to write it more generally, then let's say I'm integrating here against GK still. I have some G mu on the basis of the entire Grassmann algebra. And now what do we get? Well, so let's still use this kind of box notation where I'm saying now that the integral against GK is a mapping from GL into GL plus complex numbers. Okay. So I'm integrating here, and I can do some reshuffling. So what do I need to do? I need to put GK mu k forwards, and I have G1 mu1 until G k minus 1 mu k minus 1. Okay, I'm erasing the definition of the map. It's on the previous slide. And then I don't have gk mu, and I have gk plus 1, mu k plus 1, and then all the way until gl mu l. Okay, and why is this correct? It's correct as soon as I will add a phase factor, which is -1 summation from k equals 1, k prime, until k minus 1 of mu k prime multiplied by mu k. And what does it mean is that if I have gk here, which means mu k is equals to 1, so that becomes 1, then I need to move it through. So each time I'm moving it through something that is there, I'm getting a factor -1 to power mu k prime. So this expression here is important, and we will see it later. That's kind of why I didn't want to go to this in the session, and why I'm making those kind of mistakes by saying that it's a composition. In some way, it is a composition, but it's much more complicated to explain why it is a composition in some way. Okay, so what next? Okay, in this case, I would say that this is mu k times -1 to the summation k prime from 1 until L of mu k, not L, sorry about that. The same phase factor as above. I'm just writing it down here until k minus 1. Mu k, I can multiply it here because it will be either 0 or not, depending whether it's there or not. And then I have I have this integral, which is this here, and I don't have the integral anymore, and I have a modified expression. I have g mu plus in a binary way with eta k, which is a binary string 0, 0, then 1 position k, and then again 0, 0, 0. Yeah, so this is a quick way of removing mu k from that string. And if mu k is not there, then the integral is 0, so mu k will be 0 and the whole thing drops. So basically I have this -1, the sum g mu eta k, which is the correct expression. I have again the same Grassmann word, but without the Grassmann generator gk, or I have just simply a 0. So that's how I can define it on all monomials. What I wasn't discussing is, what didn't I discuss is that basically, what about consistency? So what about M acting on G? You take some kth entry of that, and what about G mu? Do we still have this consistency? And that demands some more calculation.